Thank you, Deirdre. We could take 2 or 3 questions on the fly. Anyone interested to share views, experience, to raise hands, and please.
Thank you. So I have a question regarding the actual initiation of this process. I mean, clearly the idea of bringing you two together is really innovative and interesting. Where did it start? Because, I mean, I'm sure all of us would like to learn how to bring about these innovative collaboration projects. Thank you.
So it started in a funny way, and I think this is something that's really unique to Cambridge, because I'm a fellow at a college, so I don't only work in my research lab, I'm also in a college. So there's a collegiate system where there's a mixture of people from all different subjects. And Trinity College, my college, also runs a program for creative artists. So they have fellowships where creative artists come in for 2 years and stay in the college and live there and work there. And so Deirdre had one of these visiting fellow commoner in the creative arts, it's called. And we basically met in the photocopier room at Trinity. And so my sister's a photographer, and I had a photograph of hers that I was sort of cutting the edges to frame. And Deirdre started talking to me, said, no, don't cut that. And, you know, I was, and so then the conversation has continued basically for 10 or 15 years. Yeah.
And I just want to add to that Sarah and I always wanted to work together, and it was the birth of my son in 2006 when the information given to me was he has an extra set of chromosomes, and parents who are told that, they leave the room and they nod and go out and think, oh, right, okay, okay, and then you go on the internet and you look and there's very little information. And I really want to understand what genetic anomalies are. And my work with the Winston Churchill Fellowship last year was all about that, looking about empowering people with learning disabilities through the arts in Canada and America. So it's very interesting how life takes your creativity into other fields if you let it happen. But Sarah and I always knew we'd work together, but it had to be something that wasn't contrived. And I think it's the beginning of something that I think we can take a lot further.
Thank you. Would there be another question? Yep.
Hiya, thanks a lot. It's really, really amazing what you can do with 4 notes. I've got a science background, but I'm also, I'd say, an amateur musician. And I'm sorry for putting a bit of a technical tone, but like, I was wondering if you have, 4 bass pairs available, then if you choose a code of 2 nucleotides, so you'll have 4 times 4, and if you say the order doesn't matter, you can divide that by 2, you'll have 8. So then you could have any note within a major scale or a mode of the major scale. And I think that'd be really cool to hear what that would sound like as well, just as a thought.
And
did you consider it?
You should write that piece, because that's your interpretation of genetics, and I think that's fantastic that you're starting to think about, okay, well, I have this background in science and I can make these patterns. And one of the privileged positions a composer has is that I can choose the material that I work with. So my interpretation of the genetic code was what you heard. I found it frustrating because I had to really stick to the pattern, and I don't normally do that when I'm writing. I normally hear something and it develops, and I hear something as it's happening and I change it. But I couldn't in this. It was a very specific task. So it's a very different piece of music from the rest of my music. But I like your idea, and I think I'd love to hear your piece. Come back in a year.
Another question? Yes.
Thank you. So, well, this would be 2 questions. So, when can we expect a full symphony with the whole genome? How long do you think it will take you to compose this? And the second part, and well, this would be a little bit on Dr. Sarah Teichmann. what you think if you find, let's say, a designer that could convert the genome into drawing the subject based on the genome information. So instead of having the music, we would have the subject being built just based on their genomic information.
Oh yeah. So do you want me to answer the second one first? So there actually, the truth is that there are very few features that you can compute directly from the code. So there are companies you can send your DNA, or I mean, they've been shut down now by the FDA. But I sent my DNA to a company to decipher, and there are actually very few physical features that they can compute directly. So they got the eye color right. But many of our traits are very complex, and our combinations of genes are determined by combinations. So height, for instance, the simplest thing, we still don't know how, what the genes are that determine our height, because they're a combination of, bone, metabolic, structural, and so on genes. There are so many genes that determine that it's really hard to compute. There are some features like eye color and blood clotting and so on that can be computed, but we're very, very, very far away of being able to draw a human. Yeah.
And about the symphony, Sarah and I are talking about a longer-term 3-year project, which I think is probably how long it would take you to do. That was 12 minutes. It took a year to write. And it's very fast. So if you're writing music, maybe take a week to write a minute of something as complex as that. If you've got 70 instruments, a lot longer. And also, it's not an automatic thing. I don't press a button. I'm making decisions about when the cello has that note, because that's what I hear. So it's quite a complex idea of, I have to remember that I actually am hearing it going along as well. And it's like opening up a little side of your head and the music's coming out. But it's not as easy as that. It's a very complex process.
So, a very last question. Anyone interested? No, because we're running out of time. So, thank you very much. We knew we had molecular cuisine, now we have genetic music. And using the CATG to conclude, it was cool, it was ambitious, it was thoughtful, and it was great. So, Sarah and Deirdre, thank you very much. Again, thank you.
Thanks, Doc.